the FreeDOS and Linux command lines are both filled with little programs and utilities that will act on files. They'll find strings in certain files and print out those lines. They'll copy files from one to another. They'll print out a file entirely. And so working with files is a great way to make your program be more useful, because now you can write and interact with a whole bunch of different files in your system. So this week we're going to go over how do you read and write files. Now I probably should be clear that there's lots of different ways that you can read and write files. You can be very advanced and write databases and do different file formats and things like that. That's more advanced stuff. I'm going to leave that for somebody else. This week, we're going to learn about how do you read and write text files. We're going to keep it fairly simple, because if you can read and write text files, you can actually get really far down the road. So we're going to focus on just that. Now, to get started, you need to know that if you're going to work with files, you need to be able to track your location in the file, and you're going to do that with what's called a file pointer. Now, if you remember when we were working with pointers from arrays and strings, the pointer really was just a way of the program to track memory. It was basically saying, yeah, this is me, but I exist over there. And a file pointer is basically the same thing. It's basically saying, yeah, this is the file, and I exist over there on disk, rather than saying I exist over there somewhere in memory. So rather than using pointers to keep track of an array, we're using a pointer to keep track of our location in a file. So let's look at a simple program that will track a file pointer by opening the file and closing the file, so we can see how to use that file pointer. So let's go ahead. I've got nothing started here, so let's go ahead and let's do a simple demo program called files.c. And when we talked about pointers before, if you remember, we had a couple of different ways to do pointers. One is that we could do an array of a static size, so we had things like an array of numbers, and we might give it a size there called 10. If we wanted to do an array that we would allocate using malloc and have to free up later using free, we would use a pointer. And so you do a pointer to an array, and then you'd need to use malloc on that, and as I said later on, free. What makes it the pointer? Well, it's the star right here. Int star is a integer pointer, and it's an integer pointer to a variable that we're tracking called array. Very similar, if you remember when we did strings, a string is an array of characters. And so we could do it the same way. We could have a character array of a single static size, and it might be something like file name. And we could allocate that to, or initialize that with something like file.txt. Or we could do a string that we would need to use with malloc and free, and we do the same way, char star string, right? And so that's how we would, different ways that you could deal with pointers. With file pointers, it's very similar, except the data type you're going to use, the variable type you're going to use, is called file, all uppercase. It's not actually a variable type, it's something else kind of behind the scenes, but you can, for the purposes of this, you can actually treat that as a just normal variable type, just called file, all uppercase. And then star makes it a pointer, and then that's our file pointer. So let's actually now write a program that uses that. Now we kind of know how to use that. Let's write our program. So let's start with our include standard IO and our main function. So I'm going to just keep track of a file name here, char file name, and then we'll call it test.txt. And now I'm going to need a pointer to my file, so I can do that in my demo program, and just do file star, and we'll call it file pointer. Now let's go ahead and open the file. And how do you open a file? We're going to do that with a function called fopen. That's going to obviously open a file. And we want to ask it, okay, what file do we want to open? I want to open file name. And what do I want to do with that file? And you're going to put that inside double quotes. That makes it a string. And a couple things you get to put in here. It's a string because you can have more than one letter to indicate certain things, but I'm going to keep it simple, so we're going to use only single letters in here. The two that you're going to get the most mileage is you can write a file using W, and that starts a new file if it doesn't exist. If a file already exists, it's going to wipe it out and start up a new one. Or you can use R to read a file. And if the file doesn't exist, we're not going to be able to read it. There's also another one called A, and that'll append to a file at the end. But I'm going to stick mostly with read and write. Now, in this case, I'm just going to open up a file for reading. Now, if that file doesn't exist, as I said, we won't be able to open it for reading. So I'll need to test in some way if I was able to open the file. So how do I know that it actually worked? Well, fopen needs to track a file pointer. So you need to, it's going to return a value, a pointer to a file. So I need to save that somewhere. And so I'm going to save that into my file pointer. And now I can test against that. So I can do if file pointer. So if that fopen worked, it's returned a pointer. And if it didn't work, it's going to return a pointer with a value of what's called null, all uppercase null, and that's a special declaration that you'll find in standard.io.h. So if it is equal to null, then I know that I couldn't open the file, probably doesn't exist. So I'll want to print out a message that says put s cannot open the file. And then I'll want to return back the operating system with some sort of a message saying I couldn't do it. Return 1. We'll return an error level on DOS of 1. Now, if I was able, and so if file pointer was null, then it didn't open. After that if, now we know that the file is open, right? So at this point here, the file is open. So I can actually act on this, doing all kinds of different stuff. Let's go ahead and first print a message that says the file is open. Oops, is open. And as I said, I can do all kinds of other things at this point that interact in the file. This is just a quick demo program, so we'll go ahead and close the file. And we're going to do that with a function called fclose. That'll close a file, and we need to give it a file pointer. So file. And that's all we need to do. That'll close the file that we just opened. And we probably should print out a message to the screen saying the file is closed. And now I can return safely back to the operating system. Everything went well, so return 0. So what have I done real quick before I compile this? All I've done is I've got a character string up here called test.txt. It's going to hold a file name. The file pointer is declared up here. Here I'm using fopen to open it. I'm checking to see if that worked. And if it didn't work, I'm going to print out a message and exit back the operating system. If it did open, then I'm going to print a message saying that. And then I'm going to go ahead and immediately close it with fclose. And then I'm going to go ahead and print a message that says it closed the file, and I'm going to quit back the operating system. So if it worked, I should get 2 messages. And if it failed, I'll get a message telling me it didn't work. So let's go ahead and save that. So let's go ahead and compile that with i16 GCC. Turn on all warnings. We're going to save the output here to files.exe. And we're going to compile the file called files.c. And if I didn't make any errors while I coded that, I won't get any messages. So there we go. And now I can run files.exe. Now, I don't have that file, test.txt. So what's going to happen? I should get an error. And there it is. Can't open the file. So let's go ahead and make a new file here. Go ahead and we'll just do a fed on test.txt. This is a line of text. This is the last line. Go ahead and save and quit. Oops. Save and quit. And to remind ourselves what's actually inside that file, not that we're going to see it just yet, but that's test.txt. And now I can go ahead and run files.exe. That file now exists, so I should get a message that says it opened it and another one that says it closed. There it is. It opened the file, and now it closed it. Now, being able to read and write files gives us the ability to do lots of different things. Real quick here, though, there's a couple of different files that are always open and available to you. One of them is called standard out. Whenever we print a message to the screen, we're using put s or we're using printf. That is actually printing out to a file called stdout. That file pointer is always there, and you don't have to worry about opening it or closing it. And that is normally going to print to the screen. But if we redirect our program, if we actually redirect files, and then we redirect it to a file called, I'll call it output .txt. Right, I don't get any output because it got sent into the file called output.txt. Because I sent it to, even though I was using put s, it actually is printing it out to standard out. And that means that I can redirect it on DOS using that greater than symbol. So standard out is always there. You don't have to worry about opening it or closing it. Another one that's in there is called standard in. Standard in is the standard input. And so normally when we read from the user, like we used scanf before, it's going to actually read from standard in. Usually that's the keyboard. But if I'm redirecting input, like I'm typing one program to another using the pipe, standard in will get redirected from whatever file or whatever program came before it. So there's also another one called standard error. So I mentioned that if you use standard out, it will redirect output. Well, what if I want to print a message and let the user know that, hey, something went wrong, and I don't want that to get redirected into the file, because it's not really part of the output that I want to have printed the file. Standard error will print that on always to the screen in this case. Standard error is the third one you can use. So you got standard in, standard out, and standard error. So now that we have all that information about how to open files and track them with file pointers and all the stuff we learned before about functions, we can actually write some really neat sample versions of FreeDOS programs. Now, one of them is the type command. So you saw me right up here using type on a file. So I did type that on output.txt. We also have test.txt, right? And all that's going to do is going to print out the contents of a file. What it's doing behind the scenes is it's opening the file for read, and it's reading the file, and then as it reads the file, it prints it out to standard out. And I know it's going to standard out because I could actually send that out to a file called, I don't know, t.txt, right? And so now it actually is stored in another file. And so it's going to standard out. On Linux, by the way, the type command is essentially cat. So we can write a version of that. So let's go ahead and write a version of type, or Linux cat, and we'll call this one fd type. So I need to start my program with include standard IO and my main function, int main. I've covered it in another video that is in the programming guide, but if you remember the way that you parse the command line options, they get stored in an array, and how many elements are in that array? Well, it's being passed in the first element called argument to main called int. It's an integer variable, and typically it's called argc. You can call it whatever you want, but most programmers are calling it argc because that's the argument count. And it's being the actual strings themselves. It's a list of strings. So that's going to be a char ***. And most programmers call that argv. You can call it whatever you want, but most programmers will call it an argv because it's called an argument vector, and that's where the v comes in, because it's a list of strings. We're doing an fd type program. I want to basically, for every file that is on the command line, I want to open it, and I want to print out its contents and then close it. I can actually get there a lot faster, a lot easier, I should say, if I write a function, and we'll do this one as a void, right? Remember that doesn't return any kind of value. So if you're doing a void function, it doesn't return a value. And this function is going to be, we'll call it show file. And I'm going to pass it a file pointer and let the show file function do all the work. So file pointer, and we'll call this variable from. It's the file that's reading from. So what's inside that function? Let's do that function first. I need a variable that's going to store characters one at a time. And so these are my variables. And that's going to be a character called ch, which is actually an integer, because that's what, if you remember our programming guide, that's what getChar function, or fgetC is what we're going to use, will read. So we're going to use a while loop, and as long as that is happening, then it's going to do some stuff in here. And I need to be able to read a character, one character at a time, and then test if that character actually is the end of file or not. Because if I use if I read a character, one character at a time, it's ch equals, and then fgetC is the function I want to use, and that will get a character from a file. And so I need to tell it where it's getting the character from, what files are getting it from. It's getting it from my file pointer from. So that's the if ch equals fgetC from. If that is not equal to an EOF, oops, then it's going to do that loop. So what is it doing? So fgetC is going to return a single character from a file pointer. That's what from is. It's going to store it in ch. Now I've enclosed that entire statement in its own set of parentheses. And that means that that statement's going to execute, and then that value can be tested against something, the value basically of ch. So it's going to, get that single character, but if it hits the end of the file, it's going to return a special code that indicates it's the end of the file, and that's going to be EOF. So I want to keep doing this loop as long as I haven't read an EOF. That's what that test is doing. And once I've done that, it's very simple. I'm just going to do a putChar on ch. And remember the programming guide from earlier, putChar will put a single character back to the user, and behind the scenes it's really putting it on to standard out. And that's all this function does. So down here, my main function, let's go ahead and write something that's going to parse my command line. So we're going to do an integer variable that's going to count through my command line. And I'm going to need to hold on to a file pointer. And so we'll do this one as, let's call it file pointer. It can be anything. You can even call it from. And now I'm going to go ahead and loop through the command line. Remember this from the other video. So we're going to do a for loop. I equals 1. I is less than argc. And then every time it's going to increment I by 1. So what's happening here, right? So if we have, remember from the other video, if we're parsing our command line, and we have a command line that looks like fd type, and then file 1. So the argv, this will be an element in the array, and that'll be element 0, because it always counts from 0. This will be element 1 in the array. That'll be argv1. But it's actually argc is going to be counting for us. So if we only had one element in the array, the count is going to be 1. That would just, if we just typed fd type without any command line arguments, it would just be 1. Fd type with a file after it, is the count is going to be 2. So we want to start at the start at 1, because that's going to be argv1. And now we need to now handle that. So let's go ahead and open the file. So we'll do file pointer equals fopen. argv I, and I want to open that for reading. Now, how do I know that that worked? Let's go ahead and test it if it worked. So if the file pointer is null, then I'm going to print a message. And I could have done a printf that said cannot open the file, and then that's the name of the file, argv I. But if I do that and I'm maybe redirecting my standard output, well, then this is going to be captured as part of my output. It's going to get redirected. So I can actually use fprintf. Same thing, except I'm going to print it to a specific file pointer. I'm going to print that out to standard error. Otherwise, the command line or the function call looks exactly the same. I don't need to exit the program because maybe there's another file on the command line that I want to work with. Now, what if the file pointer wasn't null? Well, I want to do that here with an else block. So I'm going to call my function showFile with my file pointer. And then when I'm done with that, I'm going to go ahead and close the file pointer. And then it will go back and loop and pick up another file. Now, what if I didn't have any command line options? So if I had just typed fdtype without any options, my count, my argc, is going to be 1. So what's going to happen up here? Well, it's going to start out at 1. And is 1 less than 1? Because argc will be 1 if there's only one command line option. Nope, it won't be 1. So that means that, or it's not less than 1. So that means that I need to have some other test on here that actually checks if I didn't have a command line option. So what if no files listed, right? And we test that by saying if argc was 1, then what do we want to do? Well, we could do, let's go ahead and just do a show file on standard in. And so that means whatever we maybe piped into this file is going to get displayed. Or if there isn't a file, then it's going to read from standard input, which is usually the keyboard. And that's it. We're done with that, so we can go ahead and return back the operating system with return 0. So just to remind ourselves what we're doing, I've got a function up here called showFile that takes a file pointer, and it's going to loop through that file 1 character at a time. It's going to read each character into ch, and as long as that's not the end of file, it's going to go ahead and just print that single character back to the user. And then down here in my main function, I'm going to use that by looping through my command line and then opening each file. If I couldn't open the file, I'm going to just print a message about it. If I could open the file, then it's going to just call the showFile function and then close the file right away. And then if I didn't have any files on the command line, it'll just go ahead and read from standard in. And that was it. So let's go ahead and save and quit. And I16 GCC, on all warnings, we're going to save that to fdtype.exe, and we're going to compile fdtype.c. And if I didn't make any errors in my coding, there we go. Now I have fdtype.exe. So let's remind ourselves what test looks like. I'll just use the normal type command, test.txt. Now I can do fdtype test.txt. It's doing exactly the same thing, except fdtype can also work on multiple files at once. So I might have, let's say, maybe output.txt. Right, so it's reading out multiple files at the same time. There wasn't a new line at the end of my, this is the last line in the test.txt file. That's why sort of glued together like that. And this is basically what the cat command is on Linux. Now, a good way to abstract my function, let's make a copy here of fdtype. Let's see, and we'll call it fdtype2.c. Showing a file is basically, when you look at it, it's reading from a file and it's writing to standard out. What if we actually did that in the function call itself, to actually sort of abstract this function a little bit so we can use it in lots of different ways? Rather than showing a file, we're really copying a file, and we're copying it from a file pointer, and we're going to copy it to another file pointer. And so down here, instead of putchar, we're going to need to do a function call called fputc. So just like we were using fgetc up here, which would get a single character from a file, here we're going to put a single character to a file. So I need to tell it what character I need to write and then where it needs to go to. There you go. And now I've just adapted my copy, my show file function to now be a copy file function. It's going to read from one file pointer and write to another file pointer. Now down here, I'll need to track that. So we'll go ahead and we'll change this from file pointer to, we'll call it source. And we'll do another one called dest. Oh, actually, we don't even need dest at this point. We'll get to that next function here, but we'll go ahead and change this source also back to file pointer. Now I need to modify my command line, or my function call down here. Instead of show file, it's going to be copy file. And we need to copy that from a file pointer and copy it to standard out. Then same thing down here. Instead of show file, we're now calling it copy file. And we're writing it to standard out. Very minor change to my program. Go ahead and save and quit. And then I16 GCC, turn on all warnings. We're going to write that out to fdtype2.exe, and we're going to compile the fdtype2.c program. If I didn't make any errors, then it should just come right back. And fdtype2 on test.txt. Right? There we go. So it's still the same program. And by the way, if I didn't have any command line options, then it would just read from standard in. So hello world. Control Z to end. And so that's what we've modified our program to be slightly different. Instead of showing a file, it's actually going to copy from one file and copy it to the standard out. Now, copying a file, you can probably see where I'm going with this. It's actually one step away from the copy command. On Linux, that's CP, but that would copy a file, so fdtype2.c to, we'll call it fdcopy.c. All right, so we want to be able to copy one file to another, so let's go ahead and now edit fdcopy.c. So let's go ahead and modify this to copy from one file and write it into another file. And for that, now I need to go ahead and change this from file pointer. I'll change it to something a little more meaningful called source, and we'll do another one called dest. And rather than loop through the command line, let's get rid of all this. So what's my usage on this? So my usage is going to look like fdcopy from a source to a destination. That's what I want to do. So I want to check to see if that's the usage that's been given to me. So I'm going to test with argc. And what am I testing? Well, if it was just fdcopy, argc is 1. If you gave me fdcopy plus 1 file, argc is 2. That's the count is the argument count is 2. And if you gave me fdcopy plus the source plus the destination, argc will be 3. So I want to test first if you gave me the wrong number of command line options. So if argc is not equal to 3, then I want to print out, I'll do an fprintf, standard error, wrong number of command line arguments. And let's actually print out the usage, just because we're nice to our user. fdcopy source test. And probably should return back the operating system, let them know that that didn't work. So we're going to give it a return code of all 1. Now I want to go ahead and open the files. So let's go ahead and open source as fopen. And what was the first command line file? And that was argv1. And I want to open that for reading. And I'm also going to want to open up the destination file, open argv2, and open that for writing. Now, what if it wasn't able to open the source file? Well, we probably should print out a message about that. So we say if source is equal to null, that means that fopen returned a null file. It wasn't able to read the file, which probably means the file doesn't exist. And so I want to print out a message to that effect saying fprintf to standard error cannot open file for reading. There's the file name. That was argv 1. And then we'll turn back the operating system. I don't need to close it because it didn't actually open it, so we'll just do return 1. What if I wasn't able to open the destination file? Well, let's just go ahead and check that. If the destination file was null, right? So it might be that the file is on a read-only file system, like a CD-ROM or something, or for whatever reason it can't open up that file for writing. Then it's going to print out a message to that effect. So fprintf on standard error will say cannot open file for writing, and we'll give it the name of the file. That file name was argv2. And then before I close, I should be a good programmer and close my my source file because I already have it open. And then we'll go ahead and return with an error code. We'll call this one 2. All right, so at this point, both files are opened. And now I want to go ahead and copy the file. So how do I do that? Copy the file. And that's just with copy file from, source and dest. There you go. The hard work was already done for me in the copy file function. And once I've done that, now I can go ahead and close my files. And so I'm going to go ahead and close my destination file, and I'll go ahead and close my source file. Everything was happy, so I'll return back the operating system was 0. So, I've already got one in there. So as a reminder here, what we've done, we made that minor change to copy file before, right? We didn't have to modify it this time, so it's going to copy a file from one file pointer to another file pointer. And then down here, my main function, I'm checking my command line. I'm making sure that the usage looks like this. And now I'm going to open up the source file, make sure it worked. And then I'm going to open up the destination file for writing, make sure that worked. And then once they're both opened, I'm going to call copy file. and then close my files, and I'm done. That's all there is to it. So let's go ahead and save and quit. And I16 GCC, turn on all warnings. I'm going to write that as fdcopy.exe, and we're going to compile the fdcopy.c. And if I didn't make any errors, oh, I have an unused variable. All right, fdcopy.c, because I forgot to, I no longer need that int I. I could have left it, it was just a warning, but let's go ahead and be good, and we'll compile things without warnings. Recompile that, and that should come back clean. There we go. And now fdcopy on, we'll say output.txt, and we'll copy that to out.txt. And if I do a directory, you can see that output and out are both the same sized file. And in fact, if I type out using fdtype output.txt and then fdtype on out.txt, they are the same file. But it works the same way if I do a binary file. So I can do fdcopy on the fdcopy.exe file, and we'll call this, I don't know, unimaginatively, we'll call it fdcopy2.exe. And if I do a directory, you can see that fdcopy and fdcopy2 are the same sized files. And if I run fdcopy2 without any command line options, you can see I get the error message that I expected I would get. So we're now able to write these simple versions of the of some FreeDOS commands, also some Linux commands. There's another one which is under FreeDOS is called find, and so just looking at that output file again. So type output.txt. Has two lines in it. The file is open, the file is closed. So I can do find the word open. So it'll find all lines that have the word open in it from output.txt, and I'll print it out to the back of the screen. That's basically under Linux. That's basically fgrep. So how do I write that? We actually can write that. Let's go ahead and write a version of that. We'll call it fdfind. And we're going to go ahead and write include standard IO. We're also going to be using a function that is not in standard IO. It's in another area called, it's defined in string.h. And that's for a function called stir. We'll get there in a second. So let's go ahead and write a function that will find a string in a file. So let's go ahead and do a function called int find stir file. Call it that. Now, what's my function argument list look like? I probably should have it tell me, or I probably should know what string I want to find and what file I need to work in. Right, so there's my file pointer. And then let's write the contents of that function. I'm going to need to read a string from the file. And I'm going to need to have a place to store that. So let's go ahead and just create a string of a single size. Let's call it char line from file. I'm going to make this big enough so that I know that I always can have enough room for it. Let's call it 1,000 characters. And then I'm going to need to have a pointer back to a string. I'm going to do that with char star, and we'll do that as found string. We'll see why in a second. And then as long as I'm writing an integer function, I might as well return back the number of times I found something. So num found, which I'll just initialize to 0. Now, I'm going to want to loop through the file and look for the string in any lines that I read. So I want to do a while loop somewhere in here. And what does that while loop look like? Well, before, remember I did reading a character at a time and then testing if that worked. Similar concept here. So I'm going to do while f get s. So before we were doing f get c, where we were getting in that case it was a character at a time from a file. Here we're getting an entire string from a file, and that has this calling syntax. We need to know where it's coming from, so or rather know where to store it first. So we need to have line from file. That's why I made it so big. Oops. Line from file, and we need to tell it how wide that string is. Right? How long is that string? So it knows where to stop. And so I made that 1,000 characters long, so I'll give it 1,000 in here. And then where's it reading it from? It's reading from file pointer. And then as long as that is not null, because that's what will happen if it's not able to read from the file. So as long as it's able to read each one of those, then I can do some stuff. So we're going to use the stir function. Stir is going to find one string inside another. So what do I want to do? I want to find in the bigger string, which is this first argument, the line from the file. What string do I want to find? Well, string. That's the one we passed up at the top. And that's going to return a pointer to a string inside the line from file. And so that's going to be, basically it's going to return a pointer to the first instance of string inside line from file. And so I need to store that somewhere. So found string equals stir. Now, how do I know if that worked? Well, if it worked, it's going to return a pointer to that string, and if it didn't work, it's going to return a null value. So I can test for null. If found string is not equal to null, that means it found something. So say it found something. Found, more specifically, the string. Now I can go ahead and I could do a put s line from file. But if I do that, well, f get s up here is reading one line at a time, including the new line. So if I try to print that out, it's going to print that string, including the new line, because that's what I read. And then because it's put s, it's going to put a new line at the end. So I actually don't want to use put s. I actually want to use print f. Otherwise, I'm going to get two new lines at the end. So here I'm just going to print out a string with no new line because that's contained in the argument line from file. And then let's go ahead and increment num found equals num found plus 1. And then that's my if and that's my while. And then now that I'm done, I'm going to return the number found. Now, just remind ourselves what that's doing. It's going to read through the file one string at a time instead of one character at a time. It's going to read it one string at a time, and it's going to check for a substring, a smaller string inside each of those lines. And if it found it, then it's going to just print it out. That's all it's going to do. And so then down here, my main function, int main, and our argument list looks like int argc char argv. I'm going to need to loop through my command line. So we'll do an int I. I'm going to need to open a file as I go. So do a file on, I'll call it pointer. And then I'm going to need to know a string, because that's going to be on the command line. And so we're going to do char stir, being unimaginative. All right, so let's check my usage. So the usage should look like fdfind, and then a string, and then possibly one or more files, right? That's what my command line should look like. And reminding ourselves, if it was just fdfind, argc is going to be 1. And if you gave me fdfind with a string, because I need to know the string, argc will be 2. So if argc is less than 2, that means I don't have enough arguments on command line. Oops. And then I want to print out a message to that effect, fprintf, and standard error. Wrong number of command line arguments. And then I'll be nice to the user and print out what that is. Fprintf, standard error. The usage is fdfind, string, and then one or more files, right? And then I'll return back the operating system with a code of 1. So let's go ahead and save onto that, or hold on to that string. So save the string. And how do we do that? Well, argv1 is a pointer to a string. So we've got a pointer to a string as char stir. So we're going to do stir equals argv1. That's all you have to do. That's a pointer to a string. argv1 is a pointer to a string. And stir is also a pointer to a string. So each side works. Now we need to open each file and find the string. So I need to do a for loop. This time we're going to start I at 2. I has to be less than argc. I equals I, oops, plus 1. And I'm going to open my file. And I'll save it into pointer. Fopen argv I. Open that for reading. What if it didn't open? If that file doesn't exist, I probably should alert the user of that. So if pointer is null, then we're going to do an fprintf to standard error, saying cannot read file. Oops. Cannot read file. ns. And then the file was argv I. And I don't need anything after that because there might be another file to read. So if it was able to work, then I'll do an if or an else. And then I have a function now that will actually read the file and check for the string. So find stir file, oops. And I want to open up, or I want to use find that string in that file. And then when I'm done, close the pointer to my file. There's my else. There's my for. And then what if no files were given? I want to check for that. So if argc was exactly 2, well, that means that you gave me fdfind and then a string, but no files. So that's what I'm going to test here. And in that case, I can do a. I've already saved the string. So in this case, I can just do find stir in that file of the string on standard in, which I don't need to close because standard in, standard error, and standard out are all things I don't need to worry about closing. But that's all I need to do. And now that that's done, I can now quit and then return back the operating system with error code of 0. That means everything worked fine. So just remind ourselves here of what's happened. I've already got the function defined up above. My main function is first going to check the command line arguments. Do I not have enough? Do I at least have the string on the command line? And if I don't, then it's going to go ahead and print out a message to that effect. Otherwise, I can go ahead and save that string into a pointer for later use. And now I'm going to loop through my command line. And I'm going to open each file that's on the command line and check if it worked. And if it worked, then it's going to use the find stir file function to find a string in a file. And then it's going to close the file. And if I didn't have enough command line options, if I only had the string, then it's going to go ahead and do that same thing on standard in. Done. Let's go ahead and compile that. So I16 GCC and turn on all warnings. We're going to save that as fdfind.exe, and we're going to compile the fdfind.c. And didn't make any errors. There we go. I'll come right back. Let's remind ourselves what's inside this output.txt. So type output.txt. And let's go ahead and do fdfind for the string open in the file output.txt. That's what we find. fdfind the word closed in output.txt, and it gives me the file is closed. And remember, it was checking for a string. That string doesn't necessarily need to be a word, so I could do fdfind on the string fil, right? That's the part of the word file, so that will definitely match both lines, and I should get both lines back. There we go. And so that's a simple way to write the fdfind command. As I said, under Linux, that's basically grep. And I'll stop there and I'll do another bonus video about how to use buffers. So here we've been reading one line at a file, one line at a time, one character at a time. It turns out that's not as great for performance. So I'll show you in the next bonus video how to read data all at once using buffers. But for right now, I'll close out. But before I go, let me remind you, this channel is definitely supported by patrons, and I thank every one of you who has supported me on Patreon. Some of you have supported me at a higher level, and I want to recognize you here. Thank you very much. Visit us on our website at freedos.org. Join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.